Hello friends, welcome to Learner's Planet. Friends, in this session I am solving some queries sent by a student. The problems are based on number system, are useful for this specifically for CAT exams. The question is 4 is to 44 is divided by 44 or 19 is to 95 divided by 95. In both the cases, what will be the remainder, right? Obviously, the numbers are very big and as well as divisors are also very big, so you cannot go for the direct division. But the problem this type of problems are very frequently in fact are asked in CAT examinations, right? And to solve this sort of problems, you need to be algebraically and logically clear. Just do not put any sort of shortcut. The logic of that particular shortcut, if you don't know, it will be really unhealthy. Okay, so just try to understand the logic behind that, why it is happening and how it is happening. Just blindly do not follow any shortcut. Okay, so just to understand this logic, though I have already explained the logic in my division remainder session, but further, well, just make a quick recap over here. See, any expression, suppose it is x plus y whole square plus or minus, that will be x square plus minus 2xy plus y square, right? We have got three terms when we are expanding it. Now what happens in the entire expansion? If the entire expansion is divided by x, what will be the remainder? I'm talking about remainder, not quotient. Be careful. See, if I divide this term by x, I'll be getting remainder as 0 because x square is there. Here, x is factor, so here also I'll be getting the remainder as 0. In this case, y square, if it is divided by x, since we don't know the value of y, the remainder will be y square, right? This. Okay. Similarly, if we divide the entire expression by y, then x square will be the remainder. And if we expand the same rule for x plus y whole cube, then what will happen? X cube plus 3x square y plus 3xy square plus y cube, right? So in binomial expansion, what happens whenever you expand the numbers, this expression, each and every term is multiple of both the terms except the one term, that is x cube and y cube, right? X cube will not be divisible by y and y cube will not be divisible by x, right? If x and y are not factor of each other's. Okay. So if you divide this expression by x, what will happen? The remainder will be y cube. If you divide this expression by y, the remainder will be x cube, right? Suppose I put up an example. Say if you divide 83 plus 3 whole cube by 83, the remainder will be what? See, this is factor of this. Okay, so the remainder will be 3 cube, that's 27. Okay, so if an algebraic or if a number is broken up into two numbers, when one of them is a like factor, or this, suppose in this example, if we see this is factor or this number itself is this, then the remainder will be obtained by the other term, as we have seen over here. Okay. Similarly, if we have the expressions like a plus b into a plus c into a plus d, a plus e, right? Suppose, and if this expression is divided by a, the remainder will be b into c into d into e, right? If this expression is divided by a, then the remainder will be b into c into d into e, right? Because I just take up the small example, a plus b into a plus c. So what happens? A square plus ab plus ac plus bc. Now each term is multiple of a, only bc is not multiple of a, so the remainder will be b into c. The same logic, if expanded, it can be used for this expression also, that is b into c into d into e will be the remainder if this expression is divided by a. Now it depends upon the value of a, b, c, d, e, then what exactly the numerical value of the remainder that we are going to get. Okay. If product of b, c, d and e is more than a, then further we need to take a step. We need to further it will be divided by a. Okay, I put up an example. Suppose I have number 102 into 103 into 104 into 106 into 107, and suppose I have to divide this number by 7, right? And what is the remainder that I am going to get? Now from 101, the last number that is divisible by 7 is 98, right? So this number can be written as 98 plus 4, right? 98 plus 4. So I'm just writing only 4 over here. Similarly, this will be into 5, this will be into 6, or we can write it as minus 1, right? Because 105 is multiple of 7, so 104 can be written as minus 1 from that. Similarly, it can be written as minus 2 from that. We will not touch it because this is already smaller number, right? Just try to convert the bigger numbers only. This is 1 and this is 2, right? So what will be the remainder? Just product of all these, that is 4 into minus 2 into minus 1 into 1 into 2. Now if two minus signs are there, they will be converted to positive. Okay, now what is happening? 4 into 2, it's 8. If 8 is divided by 7, what will be the remainder? That's 1. Now that 1 into 1 into 1 into 2. So that's finally we are getting 2, right? So if this expression is divided by 7, we will be getting the remainder as 2. Okay, it's as simple as that. Now I take one more example, that is the problem from previous CAT papers. 7 raised to 81 divided by 342, what will be the remainder, right? Now 342 itself is an absurd number, can't you see that? So what is the connection between these two? See, 7 cube is 343, right? So 7 raised to 81 can be written as 7 raised to 3 into 27. So that is actually 343 raised to 27, right? Now 343 can be written as 342 plus 1 raised to 27, right? And as I have described earlier, if we expand this 342 plus 1 to the power 27, will be getting 28 terms, and each and every term will be multiple of 342 except the last number and this power. So that's 1 raised to 27. Now what's 1 raised to 27? That's 1 only, right? So if this expression 7 raised to 81 is divided by 342, the remainder will be 1 only. Okay, so very simply you have applied this logic, but apply the logic only when you are algebraically or logically clear. Okay, now if any twisted problem is asked, then also you'll be able to solve. Okay, now I come back to your query. That's the first one. I take 19 raised to 95. If it is divided by 95, what will be the remainder? Now 95 is a multiple of 19. 95 is actually 19 into 5, right? We know that. So this problem can be made some simpler, right? Now how do we make that? See, if we again I'm going to explain the logic by whatever I'm doing. Now what happens? See, if you divide a number, you can say dividend is equal to divisor into quotient plus remainder, right? Suppose I have dividend, say AX, and if I divide this by BX, right? You can see X is common factor, as we can see over here. Now forget this 95, but this 19 and this 95, we have 19 as common factor. So similar pattern I'm taking over here. AX is divided by BX, right? I take out this. I don't use X. I proceed with A and B, right? So A will be what? B into quotient plus remainder, right? Obviously, whatever the remainder you are getting over here. Now, if I multiply this expression by X, what will happen? AX is equal to BX into Q plus RX. Okay. Make the comparison. If A is divided by B, R is the remainder. If AX is divided by BX, then RX will be the remainder, right? You know this. So if you know this, by applying this, then also you can find out your remainder. Now listen to me carefully. 19 raised to 95, I write it 19 raised to 94 into 19, and 95 I write it 5 into 19. Now this is actually your X. A is 19 raised to 94 and B is 5, and this is your X that I have taken as common. So what I'll do, By using this, I'll be finding out the remainder in this case. Okay, so whatever is the remainder, that will be r, and if I multiply that r by this x, that is 19, I'll be getting the remainder of this expression. Okay, now when you have to divide by 5, the unit digit of this is only the remainder, obviously. So 19 is to 94, the unit digit will be 1 only. So if you divide 19 is to 94 by 5, you'll be getting the remainder as 1. Okay, or this even power of 9 will always end in 1. Okay, so remainder is 1. In this case, that is r is 1. So if we consider x, then the remainder will be rx, that is 1 into 19, or we can say 19. Okay, so this is the logic behind that. That should be clear in your mind. Okay. Now similarly, we can discuss 4 raised to 44 divided by 44. What will be the remainder, right? Now it's 4 raised to 43 into 4, and this is 11 into 4, right? This I'm taking it as common, right? Now 4 raised to 43 divided by 11, what will be the remainder? We have one number that's 32 in the power of 2, that's 2 raised to 5. First of all, I can write it as 2 raised to 86, right? Now 2 raised to 5 is 32, and 11 threes are 33. So we can make a direct comparison. Now 2 raised to 86, 86 is not multiple of 5, so directly we cannot write 2 raised to 86 in the form of 2 raised to 5. So what I'll do, it is 2 raised to 85 into 2, right? Now 2 raised to 85 is what? 32 raised to 17. Okay. Now 32 raised to 17 into 2. If it is divided by 11, what will be the remainder? 32 can be written as 33 minus 1 raised to 17. This 2 we are having extra. So 33 is divisible by 11. So remainder will be minus 1 raised to 17. So minus 1 odd power, so the remainder will be minus 1, right? So that minus 1 into this 2, that's minus 2. Okay, so if you divide this expression 32, this entire expression by 11, you'll be getting the remainder as minus 2. So minus 2, if it is remainder, then the actual positive remainder will be 11 minus 2, that is 9. Okay, now we have already taken this 4 as common. So whatever we have got the remainder over here, that's 9 into that 4, that's 36 will be the actual remainder when 4 is to 44 is divided by 44. Okay, I'll explain it once again. Listen to me carefully. 4 is to 44 and divided by 44. I have taken 4 as common. Now 4 is to 43 can be written as 2 raised to 86 because we have a number 2 raised to 5 as 32, right? So I'm trying to convert this 86 into multiples of 5. So that's actually 2 raised to 85 into 2. Now 2 raised to 85 can be written as 32 raised to 17. 32 is closer to 33, so that can be written as 33 minus 1. And if 33 minus 1 raised to 17 is divided by 11, the remainder will be minus 1 only because it is minus 1 raised to 17. That minus 1 into this 2, that's minus 2. So finally the positive remainder will be 11 minus 2, that's 9, and the number that we have taken as common, that's into 4. 9 into 4, 36 will be the final remainder. Okay, so if you are logically, algebraically clear, any remainder problem can be solved very easily in the 25 to 30 seconds, right? Once you are clear, you don't have to write these many steps also. Okay, just do practice with the, some of the problems. I put up one example from my side. 4 raised to 64 divided by 6, what will be the remainder? Again, between 4 and 6 we have a common factor, that's 2, right? So 4 raised to 64, I write 63 into 4, or to make it simple, what I do is I write as 2 raised to 128. So 2 raised to 127 into 2 and 3 into 2, right? Now 2 raised to 127, that can be written as 3 minus 1 raised to 127. Minus 1 raised to odd power will be the remainder, so the remainder is minus 1. So if we divide this expression by 3, the remainder is minus 1. That means it is 3 minus 1, 2, right? Now already 2 we have taken as common, so that 2 into this 2, the final remainder will be 4. Okay, this is the problem from CAT previous year paper. Okay, now I am sure you got the concept.